So next, we're going to talk about a concept called tightness or bounded in probability. Um, so what it means is that if Fn is a sequence of probability distributions, we say the sequence Fn is tight or bounded in probability if for epsilon greater than 0, there exists m or epsilon such that the limb soup of the tails, what I mean tails is that if you look at, sorry, there's another bracket here. If you look at the one, yeah, so that's correct. So the notation is correct. 1 minus fn m epsilon, which is actually, usually the um, distribution function is continuous, right continuous, non-decreasing from while in infinity is 0, and in minus infinity is 0, plus infinity is 1, right? So it's right continuous and non-decreasing function. So this is the upper tail, which is the portion that's close to 1. That this is the upper tail, and this is the lower tail, right? So what it means that the probability that is outside the bound of minus m epsilon and plus m epsilon, outside that bound, the probability can be as small as we want for any epsilon. Um, by we can always find a number m epsilon big enough to make this limb soup as small as possible. Another easier way to see this is similar to the convergence in probability. We want to look at the tails. We want to look at the probability that is outside of the m epsilon, right? So the top part, so the right tail and the left tail, this probability can be as small as we want, um, you know, when by choosing the right m number. So that means that the tightness means that the probability doesn't escape to infinity uh, in this sequence Fn, where n goes to infinity. So that's tightness. So it's being packed in a finite range. So the probability that goes to infinity can be as small as we want. So that's tightness or bounding in probability.